Other people over 3x.
If you did not give me 21 and assignment 10 last class like I asked, this is your last chance to still get full points on them.
I was out here Monday, so where are the handouts for Monday?
To get those off the website, typically.
Okay.
Your handouts are all better. Fine. They're in that basket, but you need to start making up your work. By Thursday, you should be finished, not starting.
Thank you very much. Will you please stand as you're able for the service? To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Great day.
All right, morning guys. So our class today is going to be pretty similar to last class, where we're going to start off with the circuit and then finish up by giving you more time on the extremely long book assignment from like 3 classes ago. So I'll go ahead and get you started on the circuit here in just a second, but this one's number 22, and unless you just happen to need extra time, I really feel like you should finish this up in class, so I'd like you to turn it in as you finish it. So you've already seen product rule, you've already seen quotient rule. We are just practicing those some more, just like we did with power rule last time. You had seen power rule before, but you saw within that you still had some questions. Some of the questions were still take some effort and some learning. So that's what we're going to do with that part. And then the book assignment number 20, I'm asking that you do 10 more of those in class, and I'm sorry, just finish up whatever you have. You should have 10 or less if you've been keeping up with what I've asked. So I will ask for the book assignment next class. That is a longer assignment. So most of our assignments are just out of 10 points. They're all basically worth the same. If we ever have a really short assignment, I'd only make it out of 5. But really long assignments like that book assignment, I will make out of 20 to try to make it fair for how much time you had to put into it. So that can be good, that can also be bad. If you don't have it finished tomorrow, then I guess late credit would be making you miss out on 10 points instead of just 5 points. So again, if you've been keeping up with what I've suggested, you should really, I think it's like 8 or 9 questions, but less than 10. So that's the plan for today. Now the book assignment, you can turn in the Google Classroom. I will also ask for it first thing in the morning. This is a B week, so I will see you guys again tomorrow. So as I mentioned a couple weeks ago before your first quiz, sometimes you guys get extra time, Thursday to Tuesday, and then sometimes you get less turnaround time, Thursday to Friday. So nothing I can do about that. It's just the way it is. So, all right, so the first thing I'm going to recommend to you on this circuit, and again, you've seen the product rule, you've seen the quotient rule. If I asked you to get out your notes, you should probably have a pretty good start on the first few questions, but since this is just our second circuit of the year, I'll go ahead and remind you of the process with the circuit. But the other suggestion I'm going to give to you is, so you're not having to flip back and forth through your notes a lot, you might want to just go ahead and write down what the product rule is at the top. The product rule is when you try to multiply something by something, and I'm going to call it U times V, just generic U, generic V. So, in the product rule, this is where we take the derivative of one of them and leave the other part alone, and then add, and then do it in the opposite direction. That's what you've been chipping away at in that long book assignment. Memorizing that process. Likewise, I think it's probably worth jotting down the formula for the quotient rule as well, so that you can just glance up at the top of your page. Now, of course, as you work more and more of these, you should try to be referring to this less and less, or at the very least, try it and then compare to the top of the page to make sure you followed the pattern correctly. But quotient rule is when you have something divided by something, something in terms of x divided by something in terms of x. So this is the one where the order does matter. This one, the order does not matter because the order that you add things in doesn't matter. But with quotient rule, it has a minus sign, and so the order does matter. You have to do derivative of the numerator over the times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Now, again, if you'd rather use f of x's and g of x's like we did in the notes, it's still the same two formulas. I like u and v because they're kind of condensed. It's just a little more efficient way to look at the formulas. And then the other reason I like to think of it as u and v, just as a suggestion, is sometimes a question might say, I don't know, there's like this one, where f is not the numerator, it's g, and g is not the denominator, it's f. So if you memorize it strictly as f prime g minus g prime f, that's not the case here because these are flipped. If you think of it as u over v, then it'll always be the same. So that's why I like u and v instead of functions, but whatever works for you, I guess. Okay, so let's look at question 1. I'll remind you of the process here, and then I'll let you give it a go and see how it goes. Okay, so always start in the top left. This is question number 1, and so you have to figure out where question number 2 is. They're not in order, or if they are in order, it's a complete coincidence. But you should first think about whether you should be using quotient rule or product rule. Think about which one you should be using. This is 2x minus 5 times 3x plus 7. That makes me think product rule. Now, if you realize after all of that book assignment that you're getting pretty close to finishing, that you still haven't memorized these yet, then I'm going to also suggest consider making yourself write the formula down each question. That repetition that you can check on the top of the page, that repetition of writing the pattern down every single time will make it, you get closer and closer to having that memorized. Okay, so to actually take the derivative, we need to do derivative of the first term, which would just be 2 plus 0, times the second part left alone, and then product rule has a plus, quotient rule has a minus, so be careful with that. The first part left alone, 2x minus 5, times the derivative of the second part, which would be 3 plus 0. So, of course, once you have the derivative, you can start looking at your answer choices, and none of the answer choices are going to look quite like this, and that's just based on the type of simplifying. So, again, typically these questions slowly build up in difficulty. It doesn't guarantee that question 4 is harder than question 3, because some of that is just personal preference. But on this question, the simplifying looks pretty simple. We could distribute the 2, distribute the 3, and we could at least combine like terms. So we've got 12x's and minus 1. So if one of the answers says 12x minus 1, I would probably assume that's question number 2. And you should want to work that one next. Okay, here it is, 12x minus 1. So here's question 2, and then try that one second. Again, especially since they're supposed to be building up in difficulty. Now, this one, of course, doesn't look like the product rule. This one looks like the quotient rule, but I will let you try that, as you should be getting to feel pretty comfortable with this. And then the very, very last question, I don't know how many questions there are here, but the answer to the last question should loop back to the answer to question number 1. So if the last question does not have an answer of -7 over x squared, that must mean that you missed at least one question, if not multiple questions. And at the very least, you know to dig a little bit deeper. But every question has an answer that matches up, and the last answer matches up with this. That's how you know that you did them correctly. You're not going to accidentally miss multiple ones and it all work out like that. Okay, the one other thing I want to say about this, and then I promise I will shut up, is this worksheet, remember that it's asking you to practice product rule and quotient rule. So I really think that's probably in your best interest. However, just long-term good strategies, once we get to the quiz or in 3 months when you need to take the derivative of something like this, if you rather FOIL and then take the derivative using power rule, oh wait, those combine. Using power rule, then you can see you come out to the same answer. There's not one correct way to do it. Product rule is appropriate because it's a function of x times a function of x. But if you would rather distribute /FOIL and then do power rule instead of product rule, you should end up with the same answer. Your answer might look a little bit different, but they should be equivalent if you do them correctly. Me personally, I think this is easier. I can do product rule just fine, but distributing and power rule 3 times, or 2 times actually, and knowing the derivative of the constant is 0, it's just a lot quicker for me. So that's how I would personally do it, but just want to remind you that that is sometimes an option. Okay, so like we did last class, I'm going to try to let you try to be a few questions ahead. So about 5 to 10 minutes, I will let you ask about questions maybe 2, 3, 4, or 5. If you get stuck, Don't give up instantly, but if you are really hard stuck, just work a random question in the meantime and then be ready to ask about it when I ask for them. Any questions about the plan for today or what you need to be doing? Okay. Okay. Anybody stuck on number 2? Okay, how about number 3? Number 4? Or number 5? Any of the first 5 I can help with.
Is it, so number 5, not like a question like the whole problem, but
Okay, you're gonna have to tell me which one 5 is, but
x cosine x plus sine x.
x cosine x sine x. Okay, this guy's number 5.
Yeah, so you
Okay.
do the derivative, but of like the top part,
Uh-huh.
but 3, the derivative of 3 would be 0.
Correct.
But it's multiplied by the other thing, so would that just make it so that it cancels out?
Yeah, so when you do the difference quotient, the first part of it is going to be 0 times something. So yeah, all of that's going to go to 0.
Yeah.
But you should still have stuff here and here that makes up your answer.
Yeah, that's just what I was questioning. If that was okay to do.
Yep. Okay, I will give you a little more time and then offer again. Okay. So anything from first 7 or 8 questions? Yeah.
Number 6,
Okay. Which one is 6?
the second one down on the right side, on the front.
Down. So this one.
No, it's the one place.
Oh, I thought that was the front. Sorry. This one.
Yeah.
Yeah. So I did go. This is number 6. So this was one that yesterday's class also asked about, and the derivative's not too bad, but this one does simplify in a much messier way. So again, consider making yourself write out the quotient rule if you haven't memorized it yet. Even if you're pretty good at it, you don't want to mess that up. That will be several questions on your next quiz. But this has to be quotient rule because you've got a function of x divided by a function of x. So quotient rule says take derivative of the numerator. So you have to know the derivative of 1 is 0, any constant is 0, and the derivative of cosine is negative sine. That's one we just memorized. Times the denominator left alone. So that's easy enough. Subtract, then do it the opposite way. Now I'll take the derivative of the denominator. Derivative of a constant is still 0. The derivative of sine is cosine. Multiply that by the numerator left alone. And one of the most common early mistakes for calculus students is being lazy and hoping that you remember to put that denominator down at the end of the question, but you really need it each time, especially if you're using equal signs in your work. So technically, this is the derivative. So did you make it that far? Okay. So none of the answers look like this, so this is probably going to happen to you on the AP exam. You're going to do the derivative correctly. Your answer's not there. You might question your derivative, but then at some point you realize your calculus is fine. You've got to figure out how to simplify this. So my first inkling here is that they probably distributed. So maybe a negative sine x minus a sine squared x. And I'm going to guess, just based on how the question looks, I probably need to distribute this negative cosine x. There's no way to know for sure until we keep going and see if it helps. And it's still over all of the denominator squared. Now, to me, I think that this is helpful, but this is what's really hard for you all to see. And if you skipped pre-cal last year, you're at a very big disadvantage here. Because in all of this mess, of this numerator, there's two things that stand out to me. There is a sine squared and a cosine squared. Isn't there some trig identity that combines sine squared and cosine squared? Okay, what is that?
Sine squared plus cosine squared equals 1.
Okay, and I actually have that at your desk still by your desk number. So obviously in pre-cal you memorize that. If you skipped pre-cal, you need to memorize it well enough that you can hope that you can recognize this. So I want to replace negative sine x squared minus cosine x. So I can multiply this side by a negative as long as I multiply that side by a negative. So in place of both of those highlighted parts, it's really just all of that simplifies to a negative 1. Okay, and then now I'm looking at my answer choices, and there's one where they have a sine x in the numerator plus a cosine x in the numerator plus a 1. So all of those are exactly opposite of what I have, but they have a negative out front, which keeps it the same. And then again, the denominators really just kind of along for the ride. You don't usually do anything with the denominator except to just carry it down to you're finished. So that's not easy to recognize that. I get that. But now, and a few more questions, if you get stuck in the simplifying, and you notice a sine squared and a cosine squared, you might ask yourself, is there some kind of replacement you can make that might help using sine squared plus cosine squared equals 1. Your AP exam does not make you use this identity a lot, but it will ask you to use it a couple times, so we do need to know it. All right, was that enough for 6? Noah?
Yes.
Okay, was anybody else going to ask about 6? Need something specific while it's still up here? Okay. How about questions from the first 8 or 9 then? Again, I don't want to take questions too far into it because I don't want to do a question that only helps one person. Yeah.
So, do you think that you can walk us through 8? I think
Okay.
I have it, I just don't know.
Which one is 8?
One of the identities. Bottom right of the first page, I think.
This one?
Yes.
Okay. This one, there's actually a good lesson to get out of this as well, other than just the practice, of course. So, they want you to find the derivative of tangent, and they give you a good hint. So, on this question, they give you a hint. In later questions, they're asking you to basically do the same thing, but they're not going to give you the hint. So, they say, if you thought of tangent as sine over cosine, again, important trig identity that you have to know, you could do the quotient rule on this guy, and you could say derivative of the numerator is cosine times the denominator left alone, which is also cosine, minus the derivative of the denominator, which would be negative sine, times the numerator left alone, all over the denominator squared. So, as your first step look like this?
Yes.
Okay, so honestly, this is the most important part. Learning the difference quotient. Quotient rule, I'm sorry, I always mix this up. Quotient rule, memorize the quotient rule and be able to apply it. And of course, the simplifying is just going to get easier over time. But cosine times cosine is cosine squared. Sine times sine is sine squared. And just a coincidence, but I just told you that you were likely to see this again before it's done. Sine squared x plus cosine squared x always equals 1.
And does that equal secant squared?
Very good. 1 over cosine is secant. So 1 over cosine squared is secant squared. Now, there is a much faster way to do this question. This is where I was going to say there's a lesson in this. You could have skipped all of this work in this question. How are you supposed to know the derivative of tangent is secant squared?
Our notes.
Right, it's one of the things, yeah, it's one of those that I suggest you memorize. Here's your notes from a few days ago, and it's right there. So if you're willing to memorize these, which you really should, then you can avoid all of that work, and you can just say, oh yeah, the derivative of tangent, secant squared. I don't need to rewrite tangent as sine over cosine. I don't have to apply the difference quotient. But what you're actually doing is you're deriving that derivative. You're proving that the derivative of tangent is secant squared. And it doesn't take any more calculus than you already know to be able to prove that. And I think it actually asks you to prove several more of these on this worksheet. But again, you really want to memorize those so that you can totally skip that process. But it is kind of a nice backup plan. Even in my BC class, this year, this is one of the things that we did. We derived all of the trig derivatives. So just like we did the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. And the derivative of secant is secant x tangent x. And the only things they needed to prove those for were to know a couple trig identities. Actually, it's this stuff right here. This is the stuff that they had to know to be able to prove those other 4 trig identities. Quotient rule, which is what you're practicing, knowing tangent sine over cosine or cotangents cosine over sine, knowing that first Pythagorean identity, and knowing a couple of reciprocal identities. Those are the only trig identities and calculus we needed to prove those for. So I'm only making a big deal out of that because if on a test or on the AP exam you questioned yourself about the derivative of tangent actually being secant squared, you don't just have to cross your fingers and hope. If you've got time, you can actually figure it out just like I did on that question, and it's not as bad as it sounds. So, okay, is that enough for that one? Okay, maybe one more. Anybody else have one ready in the first half of the assignment, like the first 10 or so?
Do 10.
Okay, sure. Which one is 10?
Front page, bottom left.
Okay, so for question 10, do you think it should be product rule or quotient rule?
Quotient.
Okay, something divided by something. So I would agree. So derivative of the numerator is
3.
okay, times the denominator left alone, square root of x, minus, now I'm going to leave the numerator alone, times the derivative of the denominator. What's the derivative of square root of x?
Well, that's x to the negative 1. Or, yeah.
Okay, I'm going to move the x to the negative 1/2 down here. You're okay that that's the same thing? Okay. All over the denominator squared, and the square root of x squared is just x, so that's nice. So you made it that far? Okay, then you applied the quotient rule correctly. It's just a matter of simplifying. So think about what this looks like. That gives you a hint on how you need to move forward. I've got a small fraction within a big fraction. That's a complex fraction. The good news is it's going to simplify the same way about the other complex fractions we've talked about this year. I want to multiply this by 2 square root of x so those cancel, but you can't do that unless you're willing to multiply everything by 2 square roots of x. So all of this, 2 times 3 times square root of x times square root of x would be 6x. Since these two cancel, you're left with a minus 3x minus 7. I'm distributing this negative. And then in the denominator, we can do a little bit with this. I've got a 2 and an x times the square root of x. What do you think x times the square root of x comes out to be?
X squared. I mean x and 1/2, 3 set halves. X 3/2.
Good. I didn't know if that was your final answer or not. Yeah, multiply things with the same base, you can add the exponents. So x times x to the 1/2, you can add those exponents and call it x to the 3/2. And then I think the last thing that they're probably going to do is they're probably going to combine these x's. No reason to have those like terms not simplified. And then I think right here they're probably going to rewrite this as well. So x cubed means x times x times x. X to the 1/2 means square root, and the square root of x times x times x, you'd have to group 2 of these out to bring 1 out and 1 left behind. So I would anticipate the answer to look like that. And yeah, near the top right of the back page, there's one like that. So still the same quotient rule, but my guess was you didn't think to multiply everything by 2 square root of x to get rid of that complex fraction. Okay, let me get out of your way again and let you get a few more questions under your belt. I'll leave this one up though.
what's x cubed times to the second power? That'd be x to the fifth power? Or x to the sixth power? 6, okay.
Okay, but we need to know why. You said x cubed squared.
Yes.
Okay. Well, anytime you square something, it's like multiplying it by itself twice.
Aye.
And then when you multiply things with the same base, what do you do with the exponents?
You add them.
Okay, so you could either rewrite it to come up with this as an answer, or you could rememorize this exponent property. A power to a power, they get multiplied. Same thing. But, yeah, don't just hope.
quotient rule to this. Okay, where's the first part of your quotient rule? I just did it. Okay, I know, but this is where you've got a mistake somewhere. So when you did this, you did the derivative of the numerator, which was 0. So this part just went to 0, so I understand why that part's not shown anywhere. But then it's minus this, so minus the negative plus. Yeah.
Can you do this one?
Yeah.
Yeah, somebody asked about question 12, and a lot of people asked me yesterday about that one as well. That is, it was this one. Okay. Now, this is a super important question type because this is what they like to give you a lot of on your AP exam. Your AP exam will probably have one pretty straightforward product rule and one pretty straightforward quotient rule. And you will use product and quotient rule for things later that we do later this semester. But sometimes they like to really test to see if you know what you're doing by trying to phrase it in a different way like this that maybe you haven't practiced as much. So if I want to know what h prime of 5 is, I know that I'm going to get that answer by plugging 5 into the derivative. So that tells me I need to find the derivative first. So h of t is f of t times g of t. So if I want to know the derivative of h, I'm going to have to do product rule. So product rule says take the derivative of the first times the second left alone plus the derivative of the first times the derivative of the second. So I'm just happening to be very general there. But now if I want to know at 5, so everywhere there's a t, I'm plugging in a 5. All 4 of these things they gave to me up here. So now this is how I'm going to use them. But if you're trying to use them too early, then yeah, you just don't know how they're important. But now I can see I want f prime of 5, which is 3x plus 7, times g of 5, which is 2x minus 1, plus f of 5, which is 3, times g prime of 5, which is 1/2. And again, I had no idea how to use those first things at the beginning, but I still just used the regular old power rule or product rule. And then it was pretty obvious what I needed to plug in where. And then to finish up the question, I don't know, we could FOIL this. We've got 6x squared, 11x's, a minus 7, and 3 over 2. So it looks like the last thing we could possibly do is we could combine these two like terms. Negative 7 plus 1.5 would be negative 5.5, which is like negative 11/2, I think. That might be wrong. Oh. It was not wrong. Alright, Jack, you okay with how that starts? So again, I totally understand why you would be stumped at the start of this question, but now that you have seen this, sometimes just apply the product rule formula, apply the quotient rule formula, see where the chips fall. Sometimes it's a lot more obvious after you do that, but just staring at the question, not doing anything, not knowing how to start, isn't going to help out a lot. So, okay. Let me take some other questions. Is there any questions y'all had before 12? Okay. Is there any questions in the first 15? Yeah.
Front middle.
Front, middle, right. This one?
Yes.
Now, once again, this is kind of like the very first question where I said you could do this in multiple different ways. So, you know, if you preferred foiling, you could FOIL this. and then distribute this, do all that algebra, and then do probably the power rule 3 times, I think, if you want to do it that way. I'm going to practice the product rule here because I see something times something. That's what makes me think it's product rule. So, derivative of square root of x. Now this one comes up a lot, so I've started saying this derivative pretty quickly. But remember, square root of x is like this. And so if you do the power rule, you bring the power down, you lower the power by 1, and then when you move that back to the denominator, it looks like that. So honestly, I do the derivative of square root of x so much that I have that memorized, but this is why it equals that. Okay, times that guy left alone. Product rule has a plus. Now I'm going to leave the square root of x alone, times the derivative of this stuff. So this is just power rule. Bring the 2 down, lower the power by 1. That's it. Okay, now I look at your answer choices. Answer is not there, but I do notice that the one in the top right has a piece that looks familiar to me. The answer in the top right of this question has a denominator of
2 square root of x.
correct? And so it could be that this is a common denominator question. So this term already has this as a denominator. If I want this term to have it as a denominator, I need to multiply the numerator also. That way it's like I'm multiplying by 1 and not changing the size. So now that this has a denominator of 2 square root of x and this has a denominator of 2 square root of x, I can push these together into one big fraction. Right here I've got x plus 3 squared, so we could FOIL that. Make sure you don't just square the x and square the 3. You actually have to do x plus 3 times x plus 3. And then over here I've got a big mess of stuff we need to be super careful about. But we've got a 2 times a 2, which would become a 4. A square root of x times a square root of x, which would become an x. And those are still multiplied by x plus 3. So that would be 4x squared plus 12x. Yeah, I was afraid that I forgot that. Okay, and then the denominator has a couple like terms. It's got x squareds that can combine, it's got some x's that can combine, and then that's how they came up with that as an answer. Okay, is that enough for 15?
Yes.
Okay. Anybody else going to ask about 15? Need to ask something while it's up? Okay, how about 16, 17, 18? I know that's about how many questions there are. 6, 8, 14, 16, 18. There is only actually 18. So, has anybody found any other questions I can help with? Okay, let me give you a little more time to make sure. So, I want to remind you that I do want you to focus on this one first today. So that way you can turn it in, I can grade it and give it right back to you. So when you get there, go ahead and please make sure your name's on it and bring it to me in the basket. And then continue working on the long book assignment that is finally due next class. Again, if you've been keeping up with what I've asked, I think it's like 8 or 9 questions you should have left. So I put the agenda back up for you to see that though. But I'll still keep taking questions, so I just know some people are close there. Also, our daily meme here is not funny. I usually try to make it kind of pick out one that's kind of a math joke. But I did go ahead and pick it anyway, just because it's so important to what you guys are doing. You want to take the derivative of some stuff being added or subtracted. You just do them separately and then you add or subtract them. That's what they're doing on the top of the meme. On the bottom though, if you're taking the derivative of something times something and you just take the derivative separately and slap a multiplication symbol in between, you didn't do product rule and it doesn't work that way. So you can't do derivative of something times something that way. And then the last one's showing you that the something divided by something doesn't work the way they have listed. You can't just take the derivative of the numerator, divide by the derivative of the denominator. If that was the case, we would not need the quotient rule. As much as I try to emphasize that though, just from past experience, this is like my 6th year of teaching AB, I think. There'll probably be a couple people who do this on the next quiz, and it will not be very pretty for your grade, because a big portion of this unit 2 is product rule and quotient rule. So. I would also add, since you're getting close, if there was any of these that you thought were harder than the others, you might put a star by those questions, and then when we get close to the next quiz, you would remember which questions you might want to look back at or try again. All of these questions would be good, fair questions for your quiz. So.
Mr. Townsend, this is kind of small, so I didn't want to take time out of class. But I'm up to right here, and I just don't really know where to go. I've looked at a lot of properties in relation, well, I have these two, and I just don't know what to do.
Yeah, that's just a weird way to write. Like, okay, so what you're doing looks correct.
Mm-hmm.
So technically this is correct. It's just a very unusual way to say that.
Okay.
So,
What's the usual way to say that?
well, I want to show you that what you have would still come out to be that if we kept going with it. So instead of saying, let me just write down what you have. Okay, so instead of saying negative secant squared, we could say negative 1 over cosine squared, and then divided by tangent squared. But instead of saying tangent, we could say sine over cosine.
Mm-hmm.
Okay, and then when we divide fractions, that's the same as,
Multiplying by the reciprocal.
right? So if you were willing to do that, then you can see times cosine
That
squared.
makes sense.
You get this, which ends up being negative.
That makes a lot of sense, because I've
Yeah.
been doing a few like this, and then I just get stuck.
So the other thing, so what you did, again, is not wrong, but
Mhm.
instead of saying cosine's 1 over tangent,
Mm-hmm.
since, you know, tangent is sine over cosine, so if cotangent's its reciprocal, you could have also done cosine over sine to start this, and then I think it might have simplified a little easier.
Okay, thank
Yeah.
you so much.
Yeah, but you didn't do anything wrong, it's just not in a way that looked familiar.
Uh, How did we get farther in this now?
You've got a mistake here at the beginning.
Okay.
So, the derivative of this should be the derivative of g over f left alone. The derivative of g at 5 is supposed to be a half.
That'd be right here though. That would be this.
Now, when you're looking at this, are you thinking of this as f and g? Because this is upside down. This is g over f. This is saying f over g.
Okay.
That's where I said you might want to think of it as u and v, because then you don't have that problem. Or you can just, yeah.
It gets complicated when they flip them or use a different function like h of x or something, so. Honestly, you probably could have just switched your two numerator terms and it probably would have been okay to keep going, but that's fine. Okay, I'm gonna bug you one more time for questions. Obviously, you guys can still ask while you're here, but is there any others ready to go from the circuit? Okay. If you would like me to work one out on the board, just let me know. If you want me to look at your paper to help you out, bring it up here or call me over. And I switched back to the agenda though, so you remember what to do as you finish.
I know you did this one on board, but number 15. Sorry. This part of it, what is, so you divided right to get 65. Or did I do that?
I don't know why all of this is over 2 square root of x. This would just be
Because I was
prob-
trying
like I see you have a 1 over 2 square root of
Yeah.
x right there. Like this looks okay. It looks like you're using the product rule correctly there,
Yeah.
but the product rule doesn't have the denominator.
well, I was trying to simplify it. Or not.
Okay, but
Like,
you can't just slap that down
Okay.
there. You can multiply this term by 2 square roots of x. Or actually, this one already has that denominator. So this
Yeah.
one you can multiply. Oh, wait. Okay. Yeah, maybe you did okay. You just a few steps ahead of me. You can multiply this by 2 square root of x. Now, but this guy is being represented down here, so you need to erase that. That's what the problem is.
what did I do wrong with this one? That looks good, that looks good. That looks good, that looks good. So you're good right there.
I think right here, this is a minus 5. It's supposed to be a minus 5, so I think that's correct. But you've got a negative 3. When you distribute that makes that a plus 15.
Okay, thank you.
Yeah, that's what's hard about putting the 3 on the outside instead of right next to the negative. Okay.
I'm not sure what to do after this step. Like, I got this equation.
I think you're about done.
Like, I have a 3 over 2. I just don't know how to, like, make that look like the answer, because that's the answer.
This one?
I think.
Let me do that one this way. I was gonna say that doesn't sound familiar. Oh, I know what you did. You didn't do the quotient rule correctly. When you did this, you were probably looking at the formula. But the problem with the formula is the formula is set up where f of t is the numerator and g of t is the denominator.
Okay.
So if those are switched, then you've got to apply the rules separately. That's why I was saying I like to think of it as u and v, or a and b is fine, because then you don't have that problem. Because you should be doing the derivative of g at 5, so your 1/2 should be the very first thing. So you've got a couple of those mixed up. I bet it's this and this. I bet those two are just switched.
Okay.
Try that and then see if that helps.
And then I have another question. Oh, I don't know how this simplifies into the right answer.
You could distribute this
Okay.
and distribute that. And then there's a sine squared and a cosine squared that you can replace out.
Okay.
Now you guys still have close to 20 minutes. If you don't finish the circuit in class, I will still take it for full points at the start of the next class. But make sure you also have the book assignment and that you're caught back up to everybody else. Tomorrow we will start looking at and start practicing the chain rule. And the chain rule is the last of the derivative types that you have to know how to do. Have to be able to do derivatives in a calculator, which we've seen a couple times. Got to be able to memorize derivatives, which you've already seen most of those that you have to know already. You've got to be able to do power rule, which you should be pretty good at now, product rule, quotient rule, and the last one is chain rule. But chain rule isn't a different type of derivative, it's just an additional step to the ones you already know. So that's why we need to be as good as possible with product and quotient so that we can do the chain rule step at the end, and that will be the end of the type of derivatives you have to be able to do. Well, kind of not actually, now that I think about it.
lines are always linear. So since tangent lines are always linear, I would start off with point slope. You know the points you want to go through? Okay, you only need 1 point. What's the point? Okay, so in place of x1 we can put 0. In place of y1 we can plug in 1. So the last thing to figure out is the slope. And the slope's going to come from the derivative. So, what was your equation? Okay, so the derivative of that would be 1 plus e to the x. And you want to know the derivative when x is what? Okay, so 1 plus e to the 0 would be 2. So your slope during that time would be 2. So that would be it. Obviously the minus 0 doesn't change anything, so you might write it like that. Or we might choose to add the 1 over 2. All of those are technically correct though. Does that answer your question?
Okay guys, we are down to about 6 minutes. So before I switch the screen over to the puzzle for today, if I didn't get your circuit finished, that is fine. Just make sure that you have it ready to give to me for full points tomorrow at the start of class. And if you don't have number 20 finished, that's the big book assignment. This is the last class time I gave you on that, so now the rest of it's for homework. That one you can turn into Google Classroom or give me the hard copy next class is fine.
I think there's somewhere I'm going wrong with this question.
Give it a second.
I forgot the time this in last class.
Okay, you can still get like better. Let me switch this over. Okay, did you guys do this one already?
No.
Did you do this already? Okay.
Number 27.
Mm-hmm.
Is it the quotient rule?
Mm-hmm.
Okay.
Function of x divided by a function of x. So derivative at the top would be negative 3 minus 2x times the bottom left alone minus the top left alone times the derivative at the bottom all over the denominator squared. So that looks fine.
Okay.
Then it just gonna be a pain.
Was that supposed to?
Yeah, you need to FOIL those and you need to distribute this. So negative 3x squared. Okay, minus 2x cubed plus 1. Whoa.
That's the same number.
I don't see. Okay, so this times this. Shouldn't this be negative 2x times x squared to give you negative 2x cubed?
Yeah, I had that right there. I did it in a weird order.
Oh, okay.
Yeah.
So this times this is this. This plus a 2x.
The 2x right there.
Yeah, okay, I think that's okay.
Okay.
Then I'm going to think of all of, there's a good chance it's the minus sign or something went wrong.
No.
I'm going to look at this as negative 2x. Distributed to this would be minus 8x.
Would that be just 6x squared?
This would be negative 6x squared times a negative, so
Okay.
that needs to be a plus 6x squared.
Okay.
Yeah, see, you distributed the negative for the first term, but not the second term. And then this would be negative 2x cubed, but times another negative, so that one needs to be plus 2. So it looks like you just didn't distribute that negative consistently.
Okay, and if I do that right, it'll give me the right answer.
Yeah. The other thing you can do is you could just change that to a plus and make that 2x and negative 2x, and then it's a little easier to keep up with.
I have a really quick question about 14. I'm not really understanding how we're getting all of these denominators that are multiples of 3 if we're multiplying everything by 3/2.
You're not multiplying everything by 3/2.
Why not?
Well, it's 3/2 minus
We're
all the...
subtracting things from 3/2. Sorry.
Okay, I think you have that set up correctly. Well, one thing you could do, to me this is kind of like a complex fraction. You've got a small fraction within a big fraction. So if you want to multiply this by 2, it could cancel that, as long as you multiply all of that stuff by 2 also. And
I could do that.
after that I'm not sure.
Okay.
What number is that? 14?
I think I can figure it out from there.
I do have a video of that one on the website too.
Oh, yeah.
So,
Thank you.
yeah, don't forget, if there's any of those book questions you need help with, every single one of those is worked out on the website. The circuit, I have a bunch of them worked out, but it's just the ones that my other classes and y'all asked about. Oh, I'm sorry, I didn't leave that up. Anybody do that well?
I did it well, but then I can do it like super fast and take my glasses off because I can't even see what the word is anyways.
Yeah.
So I just look at the color.
A lot of people have done that. The other classes I've shown it. Just taking off, if you have glasses, if you take off your glasses, you can't read the word, and so then your brain doesn't try to force you to say the wrong thing. You just can only see the color. So, you can also try to squint, so you can only see the color, and that can help too. But for now, it's time to go